Welcome to today's Explainer. I'm really excited to get into this one because we are breaking down the exact technical guidelines for measuring and disclosing direct air pollutant emissions in the pulp and paper industry. Specifically, we're going to be looking really closely at the SASB standard metric RRPP 120A.1. If you're dealing with sustainability accounting, operations, or environmental compliance in this sector, understanding the precise mechanisms of this standard is absolutely crucial. So get ready to take some notes.
Let me ask you a question right off the bat. Do you truly know exactly what's coming out of your facility's smokestacks? And your vehicle fleets, for that matter? It's a serious question, because for practitioners managing environmental and regulatory compliance, the stakes of air quality management have literally never been higher. Getting these numbers wrong isn't just a simple accounting error. It's a profound regulatory and financial risk for the entire operation.
Okay, let's dive into this. Here is our structural roadmap for mastering the SSB's metric RRP 12OA.1. We're going to cover the overarching air quality challenge, pinpoint the big five pollutants, contrast CMOS with engineering calculations, build out a mock ESG datasheet, and finally, talk about why accurate reporting actually matters.
All right, kicking things off with Section 1, the Air Quality Challenge, and how we manage emissions and regulatory risk.
Look, the operational reality for the pulp and paper sector is that these mills generate some incredibly complex air emissions. The standard specifically points out sources like cogeneration fuel boilers, pulp and paper pressure chambers, wood chip pulping, chemical recovery, and process engines. And sure, overall emissions from the industry have definitely declined considerably in recent years, which is fantastic, but the financial impact of abatement expenditures, that remains incredibly high. Plus, evolving air quality regulations constantly create regulatory uncertainty that facilities just have to proactively manage.
Moving right along to Section 2, let's talk about the big five pollutants. What exactly do we need to be measuring here?
But before we start naming specific pollutants, we've got to understand the scope. The standard dictates that your disclosures must include all direct air emissions resulting from all of the entity's activities. This is absolutely critical. The scope isn't just your main mill stack. It includes both stationary sources, like your production facilities, and even office buildings, as well as mobile sources, like your transportation fleets. If it falls under your direct operational umbrella, it needs to be accounted for.
All right, here they are, the big five required pollutants you've got to track according to metric RRP 120A.1. We're looking at oxides of nitrogen, oxides of sulfur, volatile organic compounds, particulate matter, and hazardous air pollutants. And I want to explicitly state a rule that applies to all of these across the board. All reporting must be done in metric tons. You take everything you've measured across your stationary and mobile sources, you consolidate it, and you report that aggregate number in metric tons.
So the crucial point here, and this is a very common technical trip-up for compliance professionals, is a specific exclusion regarding oxides of nitrogen, or NOx. The standard dictates that your NOx reporting scope must include NO and NO2. But it strictly, explicitly excludes N2O, nitrous oxide. Seriously, if you're pulling data from continuous monitoring systems, you have to ensure your data filters are set correctly to exclude N2O from this specific metric line item.
There are also some really important specific nuances required for VOCs and PM. For volatile organic compounds, the standard calls for non-methane VOCs. It defines these as carbon compounds that participate in atmospheric photochemical reactions, while explicitly excluding things like carbon monoxide, carbon dioxide, and, most importantly, methane. Now, if your local regulatory definitions of VOCs conflict with this, you are actually allowed to use the local legal definition, provided you clearly identify the source. And for particulate matter, or PM, the requirement is crystal clear. It must be reported specifically as total filterable PM emissions.
Finally, we have the fifth category, hazardous air pollutants, or HAPs. The standard defines these based on their severe health and environmental implications. We're talking about pollutants that are known or suspected to cause cancer or other really serious health effects, like reproductive issues or birth defects, as well as adverse environmental effects. Tracking these accurately is absolutely paramount, not just for compliance, but for overall community safety and environmental stewardship.
Okay, Section 3. We know what to measure, but how do we do it? Let's look at CMS versus engineering calculations.
The standard actually gives entities the flexibility to discuss the calculation methodologies they use for their disclosures. The primary methods usually contrasted here are continuous emissions monitoring systems, known as CEMS, versus engineering or mass balance calculations. Think of it this way. CEMS is basically a live video feed of your emissions. You've got sensors right into smokestacks giving you real-time continuous data. Mass balance calculations, on the other hand, are a bit more like doing your taxes using receipts. You calculate exactly what chemical inputs went into a process, you subtract what came out in the final product or wastewater, and whatever is left over is assumed to be your air emissions. Both are perfectly valid under the standard, but they represent two vastly different ways of managing your facility data.
All right, moving to Section 4, building the ESG data sheet and consolidating all of this data. And this brilliantly illustrates what a finished data rollup actually looks like. Check out this mock ESG data sheet. Notice how it tracks the source, from Stack A's boiler all the way down to the mobile transportation fleet. It categorizes the specific pollutant type, making sure to note our caveats, like filterable PM and NOx excluding N2O. It identifies the measurement method for full transparency, whether that's CEMS or mass balance. And finally, the whole shebang is aggregated and converted into that mandated unit of measure, metric tons. This is exactly how incredibly diverse operational data across a massive pulp and paper mill gets translated into standardized, investor-grade metrics.
Just to ground this back into the source text for a second, this image shows precisely where this data fits into the standard SASB reporting framework. You can see the air quality topic over on the left, mapping directly to our specific metric, RRP-120A.1, right in the center. That demands the quantitative reporting of our big 5 pollutants, with the unit of measure firmly established as metric tons over on the right. Keeping this architecture in mind is super helpful to ensure you're aligning your facility's data collection directly with the framework.
Which brings us to our final section, Section 5, why accurate reporting actually matters. The bottom line.
Because look, tracking these metrics isn't just about compliance or checking boxes. It's a pathway to genuine strategic value. The source material explicitly notes that entities that can cost-effectively manage and reduce their air emissions very often see improvements in overall operational efficiency. Think about it. If you're burning fuel more cleanly and efficiently, you're likely wasting less fuel, which directly benefits the organization with a lower cost structure. Furthermore, having a really precise, data-driven understanding of your emissions allows you to proactively mitigate regulatory risks and avoid massive, unexpected compliance or abatement costs down the road. So I want to leave you with this final provocative thought today. Take a hard look at the data systems you currently have in place. Is your reporting methodology simply checking a compliance box at the end of the year, or is it actively providing the insights you need to drive true operational efficiency at your mill? The data is right there. It's really up to you to leverage it. Thank you so much for joining me for this explainer, and I hope this deeper dive into the standard helps you optimize your reporting strategy moving forward. Catch you next time.